Welcome to the second part in this video series. In the second video, I'm going to go over the essentials of PG language, which includes the general template that all WeBWorK problems follow. And then I'll also get into the syntax of the language. This includes things like variables, for and if statements, subroutines, formulae, and along with some other stuff. So to start, PG language, PG stands for problem generation language. And essentially, PG language is like a combination of Perl language and LaTeX. So there's a general problem template that every WeBWorK problem follows. So whenever you look at a WeBWorK problem, this is probably what you'll see. So, and it occurs in this specific order as well. The first one is a description and tagging section. The second one is a macros section. 3 is a setup, that is in Perl. There's also 4, 5, and 6. You'll notice 5 and 6 are optional, but there's a PGML area, there's a hint area, and a solution area. And those are all in a language called problem generation markup language, which is a very simple language to learn. There is a way to do it instead using a more LaTeX-based version, but for the purposes of these instructional videos, I would prefer just to use PGML because it's difficult enough to learn 2 languages at the same time. So first is the description and tagging section. You'll notice a lot of hashtags here. And what those are called comments. So essentially, those are only for the reader of the code. The program itself actually ignores anything that you write in a comment. So to do those, you would just put in a hashtag and then your description or your words or whatever you like. So you notice there's a description of the problem. There are also keywords. There's a subject, chapter, section, even a date, the author, the institution that the author belongs to, even the information about the textbook. And you might be wondering what this is for. So later on, we're going to get into something called the Open Problem Library. And when you choose to upload a problem to this Open Problem Library, it uses what you've put into this section to index the problem and to categorize it, essentially. So it puts it into a specific spot based on where how you've indexed your question. The next section are macros, and you can think of these as chunks of code that we're importing that somebody else has written. And they contain subroutines that will make life more easy for us. And they're just written by the developers of WeBWorK or someone else. And that's all we're doing here is we're just importing those. We're just making those available to ourselves here. Don't worry about this section or the description and tagging section too much. You won't have to make too many changes to those. Next is the setup. As I mentioned, this is in Perl. So at the top there, you can see that I've printed the point value for the problem and its title. And just below that, just below where it says setup, you'll notice I've defined the context. And so what the context does is it activates certain functions to make it easier for you to write the problem depending on what context you're using. So an example of a context would be numeric. Numeric contexts are optimal if you're only choosing to use real numbers. There are also other contexts, so like complex, which would be only for complex numbers. There are also vector contexts, matrix contexts. So it's probably a good idea to think about which context is appropriate for your question before you start writing it. Just below that, I've also set a tolerance using the context, which is just 1%. Next is the PGML area. This follows a pretty simple structure. You just begin and end the PGML area. And in between that is where you write your PGML code. The hints area is analogous to that. It just has hint appended to the end of it. And the solutions area is also very similar. And these are all in a language called problem generation markup language, as I mentioned earlier. So I'm going to show you how to upload the files that I gave you before the workshop, along with the PNG image, and we're going to use those to get started on the first question. So I'm going to go back into my WeBWorK course, and what I'm going to do is I'm going to go down to the file manager. In the file manager, you'll see that there is actually a folder that was created for us by WeBWorK for our assignment. So you can find it right here. If you double click on it, it opens it up. And there's only one file in there. It's called blankproblem.pg. And this is by default, this is always in the folder. This is just the blank problem source file that it gives us by default. We won't be using that, so don't worry too much about that. At the bottom here, there's a section where you can click Choose File. And your file will open up. I'm going to go into the folder where I have the information that I need. So there is a PGML template that I sent you. There's also a syntax demo template and a cylinder PNG image. So sorry if this appears to be a little bit confusing. But first I'm going to upload the cylinder image and click Upload. And then second, I'm going to click Choose File again, and I'm going to upload the PGML template. These don't have to be uploaded in any particular order, by the way. Click Upload. And finally, the other one is the syntax demo template. So now we've uploaded all of our files, but currently WeBWorK is only using this, the blank problem template as a source file. So we need to change that and make sure it knows to use these other templates that we've provided. To do that, we're going to go back to the homework sets editor. And where it says edit problems, we've added 2 problems. So I'm going to click on the 2 there and scroll down to the bottom to view our problems. So you notice, recall how I specified this source file here. We're going to get rid of the blank problem.pg source file. And instead, what I want you to add here is the syntax demo file. So syntax _demo.txt is our file. And make sure you have the capitalization correct there. It is case sensitive. Go ahead and do a similar thing with the second question. Delete that blank problem template and instead use the pgml_template.txt. So those are our templates there. And for the second question, while we're here, I'll show you how to set the weight and the maximum number of attempts. It's very simple. You just click on the box and change the weight. Just type in a number. And the maximum number of attempts is analogous. If you want unlimited attempts, you would just type in unlimited. Let's do 4 attempts just as an example. And once I'm done, I would just click Save Changes. And if we scroll down to the bottom, we get no errors here, so that's good. It's found the source files, and we're not getting that error anymore. So what we're going to do next is we're going to go up to homework sets. It's just underneath courses in the main menu here. And here's our homework set, our only homework set. We only have one. Go ahead and click on that. And let's go over problem 1 first. We're going to do the syntax demo in problem 1. And then for problem 2, we'll do our example problem. So go ahead and click on problem 1. And it's completely blank. So you can think of this as being like stage here. This is where everything that you write in the PGML area is displayed. Anything you write in the setup area is not displayed. It's just a behind the scenes type thing. So you can see 2 buttons down here that say Edit 2 and Edit 3. Go ahead and click on Edit 3. There's no real difference between these buttons that I found at least. So if you click Edit 3, it takes you into this nice little editor. And here's where you edit your problem and you view the changes that you make. Before we get started, there is a very useful list of resources up here. Problem techniques, math objects, the POD, PG Lab, PGML. There's lots of useful resources just up here, which is pretty convenient in case you run into issues or you want to take a look at that. So bear that in mind. But as you can see here, here's our editor. So here's the description section. Here's the macros, the setup area. And down there's the PGML area, the hints, and the solution area. And we'll get into the specifics here in a second, so don't worry too much about that. But we need to update and change our code whenever we click Take Action. So instead of clicking View, I need you to click Update. That way, the changes that we make will actually be saved and made to the file. So let's go into the setup area and let's do some programming here in Perl. So again, yeah, this is in Perl. And the first thing that I've written in all caps is always use semicolons at the end of anything you write. It can be a major pain to go back all the way back through all of your code, trying to debug it and to find that the error you made was missed semicolon. So always write semicolons at the end of anything you write in Perl. The same does not apply for PGML, so keep that in mind. And first, let's get into variables. So if you're not familiar with programming, a variable is a placeholder for a varying expression or quantity, which is fairly straightforward. So say, for example, I had some variable b that I wanted to be equal to 1. Well, the way that I would write that in Perl is by using a $sign first. So in Perl, variables start with a dollar sign. So I'd write $b is equal to 1. Variables do not just have to be numbers. They can also be strings if you want. So I could say $s for string is equal to hello. You can even have variables refer back to other variables. So for example, $c is equal to $b plus 1. And if I click take action, this is what I see. So you can see no changes have been made here to what the student sees because we haven't written anything in the PGML area. So when I click take action, this problem viewer page comes up. And this is actually what the problem looks like to the student right now, if they could see it. So you click X to get out of there. And it's good to know what an error looks like. So I'm going to take away the semicolon in front of $b equals 1 to show you what an error looks like. So if I click take action, the page comes up and it gives me a warning. So this is the warning that you get if you miss a semicolon, and it throws all your code back at you. It tells you there was an error, gives you some details, and sometimes at the very bottom here, this is probably the best place to look, but sometimes it gives you a hint as to what went wrong. So as you can see here, it knows that there's an issue near $s. The issue isn't actually with $s, it's with $b. So it's not exact always. I would not fully trust the warnings that it gives you, but it can give you an idea and help you a little bit. But we're going to exit out of that. So that's what a warning looks like. If I put the semicolon back, then I won't get any errors. The next thing is an array. An array is, you can think of an array as like being a list of elements. Those elements can be numbers, strings, other variables if you'd like. And it's like a list of those things, and each element has like its own index. So here's an example. Let's go over an example and let's create an array. So to create an array in Perl, you start it with an @ symbol. So I would say @A, we'll do capital A, is equal to, and then open parentheses, and let's put some stuff into our array. So let's make it 3, and then let's have another thing that says string, and another thing that's $C. Why not? So here's our array. And you might ask, well, how do I access certain elements? So 3 is an element, string is an element, and $C is also an element. How do I get a hold of those things out of the array? Well, here's a little table. So let's set up a little table here to help you understand a little bit better. So the first label will be the index, and then the second label will be the element. So the first element here that appears is 3. And then the second one is string. And the third one is $C. So here are all of our elements lined up. And the index for each of these is fairly simple, but it might be a little bit confusing to get used to. 3 is the 0th index. String is the first index, and $C is the second index. So you might wonder, why isn't 3 the first index? That is because most programming languages use what is called zero-based indexing for arrays. And it's very common to see something like this. So keep that in mind, that it's zero-based indexing. So as I mentioned earlier, I might want to grab an element out of this array. So let's say I want $H to be equal to the second or the first element in $A. So I want $H to be equal to string, but I want to get it from $A. I don't want to make it myself. Well, to do that, I would refer back to $A. So we would say capital A, and then open bracket 1. And what that does is this pulls the first element from the array A. So that's how I would get an element out. So now $H is equal to string in that case. The next thing is randomization. And this is where WeBWorK is very useful, is in these randomized parameters that I mentioned earlier. So we use a function called random, which is very simple. Random just takes in a start value, a stop value, and an interval. So what does that mean? Well, what we're doing here is we're specifying the legal values that our random variable can be. So here's an example. Let's do $I is equal to random. Let's have it start at 0. Let's have it stop at 10. And let's have the interval be 0.5. In that case, what are the legal values for $I? Well, it's inclusive, so 0 is one of the legal values. 0.5 is also one of them. 1, it could also be 1.5, dot, 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 all the way up to 9, 9.5, 10. So those are all the legal values for $I. So that is what we would call a randomized parameter. Next up is an if statement. If statements can be useful in problems if you, for some reason, have to make sure that values make sense in the context of the problem. So if I'm using randomized parameters and I generate those parameters, let's say one of them comes out to be a number that I can't have. Let's say one of them comes out to be 0, and I don't want that. I can't have it being 0. So I would use an if statement to change that. So here's the layout, and this is also the syntax too. I would say if, and then in parentheses, the condition, and then open and closed squiggly brackets do this. You tell it what to do if this condition is met. So here's an example. Let's define two random variables, $A, which will be random. It'll be between 0 and 10 with interval 0.25. And let's define $B, which is equal to random. And that one will be between, let's say 100 and 1,000 with interval 0.05. Or sorry, let's make it between 1 and 1,000, actually, my bad. And so what we have here are two random variables. I've actually made a mistake there. I should use a period instead of a comma there. And what I'm going to do here is I'm just going to click take action just to make sure I have no syntax errors. And I'm good. No warning messages came up. So every now and then you should be clicking take action to make sure no warning messages come up. It's kind of good to do to program like that. It's a good practice. So I have these two random variables, and let's say for some reason I do not want $A to be equal to $B. So what's my condition? Well, my condition is if, open parentheses, if $A is equal to $B, then I needed to do something to change that. Well, let's make $A or $A equal to $A plus 1. That'll fix my problem. That's just a quick fix. And that's the layout. Now you might be wondering, why are there two equal signs here in the condition? All that is just to denote an absolute equality. If A is exactly B, then I need this condition to kick in. So now that I'm done that, I'm going to click take action to make sure there's no issues with that. Okay, good. So it's taken no issues with that, no warning messages. So next let's get into for statements. This might be a little bit confusing to explain, so I'll try and go slowly through this. For statement. A for statement is basically just a recursive loop. It's if you have something that you have to do over and over and over again, then you would use a for statement to do that for you. So here's the syntax, is I say for my $I in this interval between start and stop, do something. And carry out this recursive task between that interval. So it's best to learn this by going over an example to help you visualize what I mean here. So let's define an empty array called evens, and say I want every even number between 0 and 50 in this array. Well, how would I do that? I could fill it up myself, or I could use a for statement to do that for me and make my life a little bit faster. Here's the syntax. For my $I between the intervals 0 and 50, do this. So what does this do? Let's take it step by step. So the first value of the $I is it's 0 because it's inclusive. So $I equals 0. Well, what do I want you to do with $I now? Okay, well, let's make the ith element of evens equal to 2 times I. So first up, $I is equal to 0. So evens, let's make the 0th element of evens equal to 2 times 0. So the first run, now now evens contains it contains 0. And that's all that's in it. Okay. The second run, let's go through the second run. Now $I is equal to 1. So now it's equal to 1. So now we take the first element of evens and we make it equal to 2 times 1, which is 2. So now evens is equal to 0, 2. All right. So you can kind of see where this is going. I'll go over the third run here too. Third run. So now now I is equal to 2. So now we make the second element of evens equal to 2 times 2. So now evens has the elements 0, 0, 2, and 4. And you can see this just keeps on going recursively until I hit 50, until I hit the stop value. So that's all that is. That's a for loop. And you may find ways to use this in the code. Next up is a subroutine. So a subroutine is pretty useful if you intend to carry out the same task over and over and over again. This is where you would use the subroutine. So a subroutine takes some inputs, some variables as inputs or whatever you like, and it produces an output using those. So you give it those inputs and you tell it what to do with those, and then it produces an output. So here's the syntax. You would say sub, so start it off by saying sub, and then the name of the subroutine, and then open a squiggly bracket. And you notice these things. What are these things? What am I doing here is, well, I'm saying my variable one equals shift. So I'm telling the subroutine, or I'm telling the code, expect the first variable. So expect variable one. And what am I doing here? Now I'm telling it expect the second variable. So it's going to take 2 inputs. And then I could keep on going for however many inputs I need. And then after that, after I've told it how many inputs to expect, I would carry out some task with those inputs. And then I would return the thing that I wanted to output. So here's an example. Let's create a subroutine that takes the average of 2 values, $A and $B, or any 2 random values, not $A and $B specifically, but we'll use those in the example. So what I would do is I would say sub, and let's call it average. And I'm going to open up my bracket. And to calculate the average of 2 variables, well, the input is going to be 2 different values. So my variable one, sorry, it should be my $variable one equals shift. Okay, so expect variable one as one of the inputs. And my $variable two equals shift. All right, so expect 2 variables for your input. Okay, now we told it what to expect. What do I want it to do with these things? Well, we're just calculating an average. So I say $average equals $variable one plus $variable two over 2. That's just the average. And then now what do I want it to return? I want it to return my average back. And then I would close it up by using the closing bracket and a semicolon. So now it knows expect these 2 variables, and with those 2 variables, take the average of them and then return that average. So let's click take action to make sure I've made no issues or no errors, and all is good. So now how do I use this? Because I've only defined it here. I'm not actually using it yet. Well, to use it, we would just create a variable and we would define it as being the average of the 2 values. So to use that, let's call $AB, which will be the average of $A and $B, is equal to average $A, $B. And that just takes the average of A and B. Okay, nice. So that's a subroutine. The next thing, or the second to last thing, is a formula. And if you intend to use formula, this is how you would do it. So it's very simple. The syntax is very simple. You just say formula and then open parentheses quotes. And then you put the formula between the quotes and then close parentheses, semicolon. The syntax is pretty simple for inserting the formula. It's pretty straightforward, actually, and it's intuitive, thankfully. So let's do a quick example. Let's call the formula $G. $G equals formula. And let's just do a quick example, 2 times x as our formula. If I click take action, I get no issues. So that's $G. $G is now that formula. And we can manipulate it and we can do things with that formula. Let's define another one, and let's make use of some of these randomized parameters that we've defined. So let's call $F a formula. Let's make that formula equal to $A times x to the power of $B plus $AB ln of x. That's a nice example to kind of show off WeBWorK. And so I click take action, and I get no issues. And I have these 2 formulas, so I could define another formula if I wanted to, called $H, which would be $G over $H. Let's say it's that, or $G over $F. Sorry. So you can write, you can refer back to other formulas to create new formulas, which is really useful. And so the next thing is, well, earlier I mentioned stuff like differentiation and integration. WeBWorK has these really useful features where it can just differentiate and integrate functions for you. So as a quick example, let's differentiate $H, which is equal to $G over $F. WeBWorK can do this for you. So to do that, I would call $DH, let's just call it that, equals, and it's just $H hyphen greater than symbol capital D. That takes the derivative for you. It does it for you. And then I'm going to click take action. So it's really nice. You can see we've made use of these randomized parameters. Each student will have different constants, and it's taken the derivative for us. It's basically done all the work for us. So that's good. The last thing I want to go over is a multiple choice question. And these are pretty simple. I've actually forgotten something here. It should say pop up here. And all it does is we just create this variable called pop-up, which uses the pop-up functionality, which I've imported, that's a macro, to create a multiple choice question. So the way I do this is I would define, so let's say we have a question with options A, B, and C, and option B is correct. Then the way I would type that in is I would create a variable called pop-up, which equals pop-up. Again, make sure the casing is right. And then open square bracket, and we're going to put in a list of all of our options in quotations. So A is one of the options. B is also one of the options, as is C. Here are all of our options in this list. And then comma, I would put in the option that is correct. So in our case, B is correct. And close it out. And that's all there is to it in the setup section when you're creating a multiple choice question. So click take action. And again, no issues, thankfully. You might run into some issues, but just carefully go back through your code. If you run into issues, I recommend commenting out the most previous thing that you've written to see if that takes the issue away, and if it does, then the error lies there. So that's just a little bit of advice. We're all done with the setup section. Let's get into PGML and a couple things about that. So there's some formatting stuff that I put here, i.e. how to produce bold text, italic text, how to center text, and even make it larger and smaller, or sorry, larger. But formatting is important, but it's not the end all be all. So to write equations in line, to write an equation in the PGML area, I just enclose it with brackets and semicolons. And the syntax is pretty intuitive. If you've ever taken a WeBWorK problem set, it's the exact same syntax as what the students use to type in the answers to their questions. The next thing is, if you ever, you might ask, well, I've defined all these variables and formulae up in the setup section. Can I use those instead of having to retype out the entire equation again and again? Yes, you can. So when you refer back to those, you need to use a bracket, a square bracket, surround it with square brackets and refer back to your variable or formula. The last important thing is creating a text box, so giving the students a place to answer the question. And to do that, you just surround underscores by square brackets. And the number of underscores that you give the students is the number of characters that they have to answer the question. And right beside that, you'll notice that I have, something surrounded by squiggly brackets here. And what this is this is the answer evaluator. So the answer to your question goes here. So let's do a little example in the PGML area while we're here, because we have some things defined. So let's do a quick example. Let's say consider the function, and let's refer back to our function, $H. And actually here, let's make it a little bit more aesthetic. So let's open up an equation, and let's call it h of x is equal to, and then in the brackets, $H. And we'll close up the equation, and let's see what that looks like. So this is what that looks like. It's it's a little bit complicated, but that is what it looks like. And let's just have a simple question. Let's do two parts. Let's say part A, calculate the derivative. And to do that, let's just type in equation. Let's say dH by dx. So you're kind of seeing the syntax a little bit. It's literally just kind of writing it in as you would expect it to be, is equal to, and let's close up the equation, and let's give them a text box. So a bunch of underscores. And in the answer, we've already defined, which was $DH. So click take action. And it looks fine there. Some slight formatting issues, actually. So I'm going to click X. And as you can see here, I should probably have the dx in parentheses, so it knows to put that all underneath in the fraction. You'll get used to some of the little quirks that it has there. And for the second part, let's show you how to use the pop-up variable. So part B, I didn't really make a specific question. So let's just say choose one. Choose one of these. And to do that, we just give them a text box and then open up the answer evaluator and put up the pop-up variable there. WeBWorK knows that that is a multiple choice question now. So click take action. And here's what that looks like. So you have A, B, C, your options. You can also type in the answer. The last two things are pretty simple. So you've seen the PGML area, so you've basically seen it all, but let's just go into the hint area really quickly. And there's this variable here that says show hint equals 3. And as you can see, I've explained next to it that it just shows the hint after 3 attempts. So students won't be able to see the hint until they've attempted the problem 3 times. And let's just make this a big and bold thing. Here is the hint. Big, there it is. Here's the hint. And then in the solution area, again, here is the solution. You can see I've written the hashtags next to it to make it larger. So click take action. And if we click on the hint section, this opens up. If we click on the solution section, we see this. Okay. So that is everything for the PG Essentials section. In the next video, we're going to get into the example problem. And then after that, we'll go over the gradebook and the open problem library.